Good morning, geometry. So today, what we're going to do is the next page and a half of the week 18 notes. So by the end of today's video notes, we will be done through page 6. So yesterday we did like halfway through this 5th page, and we stopped at this part that said congruent chords and arcs. So that's where we're starting today. So that's what today is going to be about, chords and arcs, congruent chords and arcs. So the first property of these chords is that two chords are congruent if and only if their intercepted arcs, so their intercepted arcs are congruent. So the chords will only be congruent if the arcs are congruent, and the opposite will be true as well. So the arcs will be congruent if the chords are congruent. So in this diagram that we're given, if AB equals CD, so let's mark that. So AB equals CD, that means that the measure of arc AB is going to be equal to the measure of arc CD. So if the chords are congruent, the arcs are congruent as well, and vice versa. If the arcs are congruent, the chords are congruent, which is what this second statement says. Our second property of these chords is that two chords are congruent if and only if they are equidistant from the center. So equidistant means the same distance, if we didn't know that. But so they're going to be the same distance away from the center. And you would always measure the distance to the midpoint of that arc, or not arc, chord. So some statements here. AB equaling CD. So let's see, here's AB. I'll do that in a different color. It's going to show up better. So here's AB. And here's CD. Those two are going to be congruent to one another because they're going to equal each other. That means that EF equals EG. So EF equals EG. EF is congruent to EG. So they're going to be equidistant from the center. And remember, you would measure the distance from the center of the circle to the midpoint of the chord, because the shortest distance is always going to be the perpendicular distance. And since I said that, the perpendicular distance, we also know that that's a right angle. By the way, I didn't say this at the beginning, but please stick around to the end of today's video notes because I am going to go over today's assignment. I do that in like every notes video, so you should be used to it by now, but I know that some people don't. So I'm going to go over which problems you have to do, and I'm going to go over one of the problems before the end of the video. All right, so yeah, that was kind of unrelated, but back to this. So we know that it's going to form these right angles when we draw the line from the center of the circle to the midpoint of the chord. And then our other statement is that if AF equals EG, or EF equals EG, my bad, That means AB equals CD. All right, and then our third and final property of these chords is this perpendicular diameter stuff. So if a diameter of a circle is perpendicular to a chord, so here we have this diagram. We have this diameter, HC, then the diameter bisects the chord and its arc. So if AB is perpendicular to EH, or CH really, because CH is the diameter here, but you know, E is the point there, so we're allowed to use E to name it. So if AB is perpendicular to EH, and we can see that that's true because they have that right angle, then AF is going to equal FB. So there's AF and there's FB. Because it's going to bisect it. So that diameter is going to bisect the chord. And it also bisected the arc. So I can say that the measure of arc AH is going to equal the measure of arc HB. So that's what's going to happen when we have this diameter that bisects a chord, or that's perpendicular to a chord. All right, so now let's look at some examples of using this. All right, just a second, I'm just looking at something. Okay. Yeah, I don't think this third property here, I don't think that's on today's worksheet at all. That's what I was just looking at. So I don't think we're gonna have to worry about that one as much. The first two though, yeah, we do have to know that, those two. Okay, so some examples of these properties. So first we have, if LM equals 41 minus 2x, so I'll go ahead and label that. So this is LM, that's 41 minus 2x. And NP equals 7x plus 5, so there's NP, that's 7x plus 5. Find the value of x. So LM and NP are just two chords that are there, but I see that their arcs are congruent. So the arc LM is congruent to the arc NP. Therefore, I know that the chords have to be congruent as well. So if I want to find x, I can just set them equal to each other. I can say 41 minus 2x equals 7x plus 5. I'm going to go ahead and subtract 5 from both sides. So it's going to give me 36 minus 2x equals 7x. Then I'll add 2x to both sides. So I'm going to have 36 equals 9x. And if I want to solve for x, because that's all I have to do in this problem, I just have to divide both sides by 9, and then I'll get 4 equals x. So on this one, and a lot of other problems like it that you're going to see on today's worksheet, all you have to do is set them equal to each other and solve. All right, cool. So that was our first property that said if the arcs are congruent, then the chords are congruent, and vice versa. Our second property about the arcs or the chords being equidistant from the center, let's look at an example of that one. So we have that the measure of arc BC is 9x minus 53. And the measure of arc CD is 2x plus 45. Okay. But it wants us to find the measure of arc BAD. So BAD, just that one there. Nope, not like that. So BAD is the big arc. It's a major arc. We can tell because it's named with 3 letters. But that one doesn't have a measure on it. But we can still figure it out. And to figure it out, I'm going to start by solving for x. So let's see. I know that if the arcs or the chords are equidistant from the center, which I can see that they are, then the chords are congruent. And if the chords are congruent, then their arcs are congruent, meaning that this 9x minus 53 equals this 2x plus 45. So 9x minus 53 equals 2x plus 45. I will start by adding 53 to both sides. When I do that, I get 9x equals 2x plus 98. Subtract 2x from both sides. And that's going to give me 7x equals 98. And if I divide both sides by 7, I'm going to get x equals 14. But I don't want to solve for x here. I need to solve for the measure of arc BAD. So I'm going to use a property that I discussed on, I forget if it was Monday or Tuesday. I think it was Monday. So on Monday, I talked about how the arcs of a circle always add up to 360 degrees. So I know what x is. I know this arc is 9x minus 53. I know this arc is 2x plus 45. And I know BAD is like everything else. So I'm able to write an equation to solve for BAD. I can say the measure of arc BAD plus that 9x minus 53 plus that 2x plus 45 is going to add to 360. So I don't know if there's actually a special word for adding to 360. I know adding to 90 is complementary, adding to 180 is supplementary. Let me actually look that up real quick. I'm sitting in front of my computer. Yeah, no, it's just saying like circular. So yeah. Okay. Yeah, just circular. So anyways, back to the problem at hand. So I'm going to, well, actually, I know x equals 14, so that's going to be my first step. And instead of writing like all that MBAD, I'm just going to abbreviate it or shorten it to M. So M plus 9 times 14 minus 53 plus 2x, or no, not 2x, because I know x is 14, plus 45 equals 360. Then my next step can be to multiply the 9 times the 14 and the 2 times the 14. So then I'll have m plus, let's see, what is 9 times 14? It is 126. Minus 53 plus 2 times 14 is 28 plus 45 equals 360. Then I will combine like terms. So I have 126 minus 53. I'm just doing this all on my calculator right now. 126 minus 53 plus 28 plus 45 is 146. So I have m plus 146 equals 360. And to solve for m, or more specifically the measure of arc BAD, just subtract 146 from both sides. And I get that the measure of arc BAD, this time I'm going to sub in the entire thing, or write the entire thing. So the measure of arc BAD is going to equal 360 minus 146 is 214 degrees. So that would be my answer here. So we just had to figure out what x was, and then add up all the arcs to equal 360, plug in x, and solve for whichever one was missing. All right, and then an example of the third property, the one that I said we weren't going to be using as much today, or at all today, I don't think. It says if PQ equals QR, so they already have that marked for us, JK equals 3x plus 23, so that's, well, here's JK. And LM equals 9x minus 19. Find RM. So we want to find RM, which is like just half of this. All right, so let's see. This, it's not named, but this segment here with the P and the Q and the R on it is diameter, because it goes straight and it just goes straight across that circle, goes through the center. And then PQ is perpendicular to QR, or no, PQ is congruent to QR. But they are perpendicular as well, as we can see the right angles there. So that means that it's going to be bisected. So I can say that MR, actually I should mark that with 2 markings. MR is going to be congruent to RL, and likewise JP is going to be congruent to PK. And since, because of that second property we talked about earlier, I know that KJ and ML are congruent to each other. So that means that like KP will be congruent to MR if I wanted to figure out stuff with that. So that's why they're all marked with 2 little tick marks there. Okay, so as I said, KJ and ML are going to be congruent to one another because of that second property. Because we can see that PQ and QR are the same distance, therefore they're equidistant from the center. So I'm going to say 3x plus 23 equals 9x minus 19, and I want to solve for x. So I'm going to add 19 to both sides. So that would be 3x plus 42 equals 9x. Then I'm going to subtract 3x from both sides. So I have 42 equals 6x. And if I divide both sides by 6, I'll of 7 equals x. But we didn't want to solve for x, we wanted to solve for Rm, but we do need x to be able to do that. So, as I said, Rm, we're not given a measure for that, but we're given a measure for Lm. And I know Rm is half of Lm. So if I want to solve Rm, I'm able to say that 1/2 of Lm, which is 7x minus 19. Rm is going to equal 1/2, or 9x, and instead of x, I'll say 7, because we solved that. So 9 times 7 minus 19. Rm equals 1/2 of 9 times 7 minus 19. So let's see. I'm not going to distribute the 1/2. I'll just leave that outside until the end. So I have 9 times 7 is 63. So I have 1/2 times 63 minus 19. Which is 1/2 times 63 minus 19 is 44. And 1/2 times 44 is 22. Which means that the distance of Rm has to be 22. All right. So that was the extent of today's notes. I'm going to go over today's assignment just a tiny bit. So let's look at today's assignment. I believe it's called Chords and Arcs in Schoology. Yes, it is. All right. So we can see that there's like 16 questions here. You only have to go up to question number 9. Don't do past number 9. So I'll go ahead and cross out everything after 9. So don't go past 9. And I want to go over one of the problems first. I want to go over problem number 5. So on problem number 5, we have to find x. And we're given that this chord zy is congruent to this chord xy. And then we're given this 76, that's this arc xz. And arc zy is 6x minus 20. So I said that zy and xy were congruent, but I don't have a measure on xy. So, since this is 6x minus 20, I can just say xy is also 6x minus 20. So I have 6x minus 20, 6x minus 20, and 76. And remember, on a circle, it has to add up to 360 degrees. So I'm going to do 76 plus 6x minus 20 plus 6x minus 20 equals 360. And this is the equation you would use to solve for x. I think number 5 was the only one that needed a little bit of explanation at first. Let's see, number 8 here. This one, you're going to do basically what we did for the second example in the notes. But all the others should be pretty straightforward. I believe you're just setting things equal to each other and solving for a length, an arc measure, or a variable. All right, so number 5, I didn't solve it, but that's how you would set it up, and you just need to solve that equation for x. And remember, only do up to number 9 on this assignment. Other than that, that's all for today. I'll see you guys tomorrow. Have a great day.